Hello, Dino here, and welcome to the I'm relatively new to Gen AI, what's it all about guide. If you are brand new, complete beginner to Gen AI, then you are in the right place. But also, if you're an expert and maybe you've done some things in Gen AI, then you're also in the right place as well, because there are ways that Sky do it, or some tips and tricks, or some policies that you may not know about that might be useful to you. So stick around. Other than that, let's crack on. So this is actually from the big group message that went out. So thank you to Carl, Neve and Prasanna, because you've made my life very easy putting this together. However, there's 4 things I would pick out of this one and make sure that you're super aware of. First one is the whole point of Gen AI at Sky is to make things better for our customers and our people, and also to improve our productivity. So there's a lot of opportunity there. So we need to embrace that, run at it, do it positively, but also thoughtfully and responsibly at the same time. So if you can bear those 4 things in mind as we go through these videos, then you'll be in a good place. I'm going to cover 10 topics in this guide. So there will be a simple intro to generative AI. What are other companies doing with it? What does this all mean for Sky? What does the future hold? A bit of a peek there. What are some of the words you should know about? How does it actually work? That's quite a chunky subject. Who are the big players in this space? Some of the names you should know about. What are the main watchouts or issues? And more specifically, are there any legal things or policies you should know about? And if you want to get involved, how do you get involved? Just a few things, hygiene things about this deck, or at least this presentation. It's going to be chunked up into sections, so don't worry, it's not going to be a big ginormous thing. There is going to be one version of it, but also if you do want to go to one of those sections, there will be a specific video for that. Go straight to it, use it as a refresher if you need to. It's all good. I've simplified some things as well. Of course, this is quite a tricky subject, so do forgive me if you are a super expert in this. You're thinking it's not exactly how it is. I've just taken a few liberties to make it simple. And finally, this is an internal deck, so please don't share it externally. Other than that, we're good to go. Enjoy the rest of the videos, and hopefully we'll learn something and we'll get to the end of it with a few more synapses firing. The really simple intro to generative AI. Right, let's make this really simple. So first thing I'm going to mention is even AI is a moving definition. 1960s, if you saw a pocket calculator, you'd probably think, wow, that's doing what humans can do. Maybe 1990s, 2000s, you'd seen an algorithm serving adverts or maybe tracking a car down the road. These algorithms were seen as doing human work. Machine learning came along, and then we started to see maybe prediction happening that even humans couldn't see. And then neural networks even look like computer brains when you look at their diagrams of them. So they're definitely AI. But the more familiar we become with these technologies, the more we realize it's just computers doing stuff, which, spoiler alert, that's all this is. So just be aware that in 20 years' time, we'll probably be looking at today's computer-generated algorithms and thinking they're just computers doing stuff. So just bear that in mind. And AI is a really big topic. So it is a container. So computer logic that imitates human behavior is, broadly speaking, AI. Now, within that, there was a bit of a game changer with machine learning. So machine learning understands data and then can make predictions on it. Now, it can understand really complicated data. So the predictions it came out with was something that humans could not do. So it was super useful. And then the next nested thing within that is what we're currently on, which is generative AI. And by the way, there are other nests depending on what diagram you use, but generative AI can not only make predictions, but it can also make outputs that resemble the inputs. So it can create. So I would also argue that you could then go down each one of these levels, getting more creative and more useful as you go. Why are we even talking about it right now? So ChatGPT by OpenAI is probably the reason we're all talking about it. But it's been around for a long time, 70 years or so. The general subject of AI, as I've just explained. 2015 was actually quite a big moment when we had these things called generative adversarial networks. Very exciting for somebody like me. However, I just explained that because it is useful. Generative adversarial networks, or GANs as they're called. It was generative, it could make stuff up. It was adversarial, so it would battle its output against its input to try and see how it could improve it to make it the same as its input. And it used neural networks. So that's what a GAN is, a generative adversarial network. And it's basically the forerunner of what you're seeing today. That made a huge leap in 2017 with transformers, and a transformer is what the T is in GPT. So just a new type of neural network model. Won't go into it just yet. However, just know that it's made some big leaps and bounds, but it was only really OpenAI making a chatbot open to the public that made everybody aware of it, and also the press getting hold of it as well. And we could all have a go and just go, hang on a minute, this is useful. DALL-E 2 was also something that OpenAI released, so you can make your own images. Relatively crude at the beginning, but it's getting better every day. So that's why we're talking about it. It is a hype cycle, by the way. So we are everything at the moment, just as it was with NFTs or maybe the metaverse. It is in a hype cycle right now. So it will calm down. But just at the moment, we're seeing actually what it can do. We're finding whether it becomes productive or not. What sorts of things can it do, though? So we've seen chatbots. ChatGPT is a chatbot. It can also learn from scripts and write new scripts. It can summarize hugely complicated topics. It can look at things like agent chats, for instance, with customers and summarize those calls. Code generation, obviously we know what that means, but it can also do optimization. I've got some code. Can you make it faster? Yes, I can. Speech, audio, music generation. It can do images in various different ways. It can even generate videos right now. They're a bit crude at the moment, but literally every day they're getting better. It can create synthetic data. It can classify objects, and it's really good at interrogating data in natural language. So ingesting a huge amount of data and then asking it human questions. So that's basically a really, really simple version of what AI is, or what generative AI is, and what it's useful for. Right, on to the next subject. What are other companies doing with generative AI? I hear you ask. Well, let's find out with some examples as well. If you go up to any company or any industry right now and held a glass up against their window and listened, they'd be talking about AI. You can absolutely guarantee it, probably from the boardroom to the shop floor. Manufacturing, social media, smart homes, insurance, you name it. What does it mean for them? What does it mean for their customers? What does it mean for their employees? What does it mean for their data? What does it mean for the future? You name it. Point is, we are not alone. Everybody's trying to figure this out at the same time, and it has implications for nearly every industry. If I was going to call out some specifics, I would say the creative industry. So this is Adobe Firefly. This is available right now. This is in a commercial piece of software. If you don't like your image, before you needed to use Photoshop, now you can just use a text prompt. If you want a castle in the style of a something, it will do that for you. If, for instance, you wanted your dog to be dressed as Santa, you just type it in, it will do that for you as well. So you could argue this is putting creativity into the hands of the masses, but you can also argue, well, it's cheapening the creative world. But at the moment, it's not fantastic. So we still have an advantage, but it is there, it is available. The same can be said of the newsroom as well. It's not necessarily being used to generate the news itself, but actually as a co-pilot, it's fantastically useful. Write an article and then ask it, how could I improve this paragraph? If I wanted to talk to maybe an audience of under 15s, how would I rephrase this article? Can you summarize it in 10 bullet points? Can you turn it into an audio article? Can you voice that audio article with a different celebrity? All those things can be deployed in the newsroom. And also music as well. So as you can see here, I want 2 nylon string guitars playing some soulful jazz in a flamenco style with ambient soft music that I can study to. Great. It will generate that for you. So if you are in the broadcast world and you need some music, then it's an interesting thing. But generally speaking, the music world is also being revolutionized by generative AI. You've got some people who are also leaning in further. People like Grimes made every one of their stems available, their music stems, so you can create your own music, have gone even further. If you upload your lyrics to the website, it will turn it into Grimes's singing voice, and you can use it in your own tracks. Very, very happy for you to make money out of that as long as you share it with them as well. So we're seeing some artists go quite heavily into this. And also data prediction as well. So this is a model, actually a research model that was predicting stock market. And it can also, with certain models, and the way it does is it predicts all of the things that might happen, not just let's just go up and down every day. So in this case, it can actually predict a 500% return on one of its models. Some models actually went down. However, it was really good and much better than existing normal models, should we say, of prediction, just using algorithms and machine learning. So if you're a fund manager, quite interesting. And also video. So this is actually maybe a month old now. And we are far, far ahead of this right now, even in a month. So this is all generated by AI, the script, the music, the visuals. And as you can see, it's not brilliant at fingers. It's not brilliant at interfacing mouths, should we say. It's not super brilliant at laughing. It's super weird about flames. However, you can see at the moment where this is going. It's almost creating a genre of its own in the style it's creating, but it's not going to be a million miles away where you can just say what movie you want or what version of the comic that you really like and turn it into its own piece of video content. Google is looking at advertising. They already have their Performance Max platform, which is a programmatic media platform. But now, instead of having to upload the assets that create your advert, you can just go, look, I've got the product shot and I'd like it to be next to a cat. And I'd like actually some voiceover. I'd like a piece of video to actually be cut, but I only want a 20-second piece of video. It will choose the best piece of video. If you then say you want a voiceover on it, you type in what you want, and it will do the voiceover for you. It will then generate those voiceovers for every single customer so that they have the best piece of content they possibly need. Now apply that to video content or video on demand. That's also quite interesting as well. And also finally, we're seeing it actually just in the pure edit suites as well. So this is an Adobe plugin that you can put, and it will just look at things like podcasts. It will know who's speaking. It can then cut to the camera. It can hear who's saying what and therefore know what the most important thing to cut to is. So we're actually starting to see it in edit suites as well. So if you're in After Effects, for instance, it's a plugin you can use right now. So just some of the examples of how it's changing our industry and other industries as well. What does this all mean for Sky? Well, that's a very swanky title that basically says, have you got any examples and the potential uses? And yes, I have. I've got lots. Accelerating software engineering life cycles is one of them. So there's a lot of grunt work that goes on in this. So things like refactoring code or making code optimized. You've already got the code. It just needs to be better. So generative AI can help there. Efficient and effective customer service. So you want your agents speaking to customers ideally and doing the good things, and what you don't want them doing is doing summaries or writing up reports, and that's what the AI can do for you. It can also go through the entire transcripts of the day and suggest maybe some updates that you can do, maybe some tips and tricks for your agents to make sure that your customers get a better service tomorrow. Ad creative review and optimizations. So you can look, for instance, at ad creative and it can suggest and also generate improvements as well. You can either run those or you can not run those, but programmatic advertising, for instance, runs on creating those optimizations that always get you the best results. Reading legal documents and suggesting improvements. Now, legal documents are all about the nuance and the context as well. So there's not only the hidden meaning, but the actual meaning. So reading between those, it's very good at looking at those and also suggesting improvements and also suggesting basically historical things that could be improved on the current documents as well. Summarizing news and news articles. So this is very easy to imagine. You go onto the news app and you say, I haven't got time to read this. I'd love to know about this subject, but I've only got 2 minutes. Could you do it in bullet points? I only want 3 bullet points and I'd like them to be spoken in somebody's voice, but give me a tone that is understandable to a 10-year-old. It can do that for you as well. So it does not change the original article intent. It's still been written by journalists. However, depending on the context of the consumer, they can now get more access and more use out of those articles. Creating concept images and image options as well. So for instance, if you're working in a creative area or Sky Studios, for instance, and there's a new scene that's just happened and you need scamps for it that you don't currently have, well, feed in the original scamps and it will then be able to generate scamps based on some input. You can do a very crude version. It can generate those, or it can give you options as well. I've already got this. Give me another 5 ways of looking at this scene. Creating the job descriptions in a consistent tone of voice. So job descriptions need to be compliant and they also have to have certain things in them, but also the tone of voice needs to be correct as well. So just looking at things like, can you give me something that's inspiring? I've written 20 of these job descriptions today. I've run out of inspiration. Can you give me a way of writing this job description that will attract the best candidates and the most diverse and inclusive candidates as well? Translation and lip syncing of live and archive video. So a lot of cost and a lot of energy and a lot of time goes into either translating or dubbing videos. So in this case, it can not only understand what's being said, but it can regenerate a voice in a different language, and it can then redo the expressions or the mouth so that it looks like the person is seamlessly saying those words. And that can happen to archive video as well. So giving a lot of your archive footage a new lease of life. Summarizing market reports and offers and using words to do it as well. So you might have a huge report and you're not quite sure how to get the best out of it. You can just ask it what you need. So can you tell me how are we over-indexing in this market, and how might we apply that to the markets we are under-indexing in, for instance? And also just on-brand copywriting and adhering to the Sky values and tone of voice as well. So learning a tone of voice is really, really useful. When an AI can read a lot of data, it can say, I can translate that into anything new. Style transfer is another thing as well. This is our style. Can you apply that to this? So that's a really good use case example. And finally, we are already heading down this route as well. So these are proof of concepts. This is some of the use cases we're already looking at. I'm not going to read them because it would be very boring. You can pause on this slide and have a look at them yourself. But there's a lot of the things I've just spoken about already being looked at, for instance, and anywhere between concept to early experimentation to starting at scale and then into production as well. So speaking the written news content, already done that, already using it. So we are already using generative AI at Sky, and a lot of other things are following fast behind as well. So hopefully that was useful, and on to the next subject. What are some of the words I should know? There are a huge amount of words you should know right now for the generative AI. Here are 4 that I think if you knew these words, then you would survive most corridor conversations talking about generative AI. First one, well, it's actually 3 words in this one, but it's large language model, or LLM as the cool kids call it. It is an AI that has been trained on huge amounts of data, and it uses this knowledge to understand and generate sentences. Now, in other words, it is basically trained on books and websites, and it's seen so many sentences and words and letters, it starts to understand how they're put together. So it has a model of how the language works. So if you start interacting with it using language, it goes, yeah, I know how this works. And likewise, I can generate language, because if you ask me a question, I know that after a question comes an answer at a very basic level. And I even know that after a space usually becomes a capital letter, after the full stop becomes a space. It understands how that works, and that's its large language model. Say big companies have large language models, the Microsoft, the Amazons, the Metas, the OpenAIs, they take a huge amount of energy and money and time to train these things. Now, once you have trained them, they are pretty much set. So you might hear things like GPT-3, GPT 3.5, GPT-4. Those are set models that have been trained and they are pretty much done. You can use them, but they're pretty much done. So large language models are something that somebody else has and you do all of your stuff on top of it. But it's the thing that understands the languages. You interact with them using a prompt. So if you've used ChatGPT, you've used the prompt. You type those words in. The large language model knows how sentences work. So it knows the context of what you're trying to say, all that sort of good stuff. And it knows how to give you a sentence back because it is a large language model after all. But you use your prompt to tell the LLM what to do. Now, the reason the large language model knows anything in the first place is because it has been trained. So you train a large language model, but you can also train your own little bits of data here and there as well. So when you train a large language model, it's the process of teaching it to be useful. So it ingests a huge amount of data and constantly tries to generate outputs that look similar to the data. And it does that over and over again until it starts to generate random outputs that start to actually look like the inputs. And therefore it knows it's getting somewhere. It's starting to replicate its output based on its input. So that's what training is. And I say, for a large language model, it's done in one go. And as soon as it's done, it's done. And then they work on the next version. So that's what training is. Now, because it's set, what happens if you want to ask it about something that happened yesterday? It won't know because it wasn't trained because its training was set. So that's where plugins come in. So these are relatively new, but they extend the large language models by allowing it to just squirrel off and go and find some extra information. That might be a plugin that goes over to something like a travel agent or a shopping channel or something like that. Or it might also be your own database. So something like that. So for instance, at Sky, we will create plugins that do very specific things on top of the large language models. So that's what a plugin is. Now, as long as you've got those 4, as I say, you can pretty much survive most conversations at Sky about generative AI, but there are some more words and I'll try and go through them as quickly as possible. Some of them I've already covered. There are 2 sheets of these. I'll do them super quickly. Large language models, you know about those. Foundation models, I won't muddle the water here, but it's pretty much the same as a large language model in today's world. So a foundation model kind of sits below, and it's what then language is trained on within the model. So the foundation is actually the bottom part of a large language model, is one way of thinking about it. But in today's world, we mostly use LLMs, so in which case the foundation is pretty much the same thing. The model is the specific use that you're putting it to. So for instance, if you're trying to generate adverts for Sky, then you will generate a model that will sit on top of the foundation or the large language model. A prompt, we know about plugins and training. Embedding is really, I don't want to confuse you because it's in a later video, but imagine the data that when you start to train it is not in a database, it's not in columns and rows, it's in a big cloud of data. And where it sits in that cloud is really important. Where you embed each one of the examples or each one of the words in that cloud is really important. And that's multifaceted as well. It blows your mind to even think about it. The vectors is really a measure of how useful each one of those points in the embedding is. So think about a database. It just kind of gives, based on the word you're currently looking at, there might be another word that is more important that sits next to it, and it will have a very strong vector. A transformer is the process of using all of that to try and figure out what the next answer is. GPT, now you know those words. It's generative, pre-trained transformer. It is a generative algorithm. It is using pre-trained information, and it uses transformers to try and give you the answer. That's what GPT stands for. Here are some more standby embeds, neural networks. So this is a learning algorithm without which we would not be able to do any of this. A generative adversarial networks, I mentioned this right at the beginning. However, basically it's an algorithm that battles itself to get better. Diffusion is how images are generally made in generative AI. It's not the same as a large language model. Diffusion, imagine a picture of a dog that you blur into white noise. Now, when you blur it, you kind of keep track of what you changed. And there, if you start with white noise, you can turn it back into a dog. Now, if you change some things in that white noise, you can get a different dog each time. And that's how it generates new images. It's a very simple way of thinking about it. Modal is how many types of output your AI model does or your LLM does. So if you have a multimodal model, it might also, for instance, generate images as well as text, for instance. Co-piloting is more of a philosophy. So humans ideally should always be involved in anything that the AI is outputting, especially some things that humans see. So imagine a AI as your creative co-pilot is a good thing to have. Natural language processing is where computers understand words. So it's one of the sort of cornerstones of creating that large language model. Alignment is just how well that your outputs actually fitted the prompt. So you can have a really well aligned model, or you can have a badly aligned model, in which case it probably needs a little bit more training. Temperature is also part of that as well. Temperature is the value you give to the AI to say how random you want the output to be. If you have a temperature of 0 for every prompt, you will almost get a 1-to-1 output. If you start putting the temperature up, you'll start to get different outputs each time. And if you've noticed with things like ChatGPT, if you ask it the same question twice, it will give you a different answer most of the time. That's because it has a temperature setting that will allow it to do that. Attention is when encoding, it's how much importance you put onto each one of those points. And also model collapse is something important to talk about, is if you generate things and you use the generated thing to train the thing, then eventually it's just become trained. It's what's called garbage in, garbage out. So it collapses in the end. So model collapse is an actual thing that we're starting to see in some places. So those are some words. Now, if you're down the pub or wherever you want to go and talk about generative AI, this will pretty much get you through. There are lots of others, but hopefully that's been useful. So how does it actually work? That's the big question. Let's try and get through this at least live. So in really, really simple terms, it's about pattern matching and predicting what comes next. So if you take some really, really nice clean data, which is ideally what you want, let's say a little nursery rhyme, hickory dickory dock, the mouse ran up the clock struck 1, the mouse ran down, hickory dickory dock. Brilliant. So now what do you do to train yourself on that? What you're ideally looking for is patterns. So hickory dickory dock seems to appear twice. Mouse ran appears twice. Up and down, they seem to be connected. I see those a lot connected together. They seem to be the same sort of thing. The clock appears twice, but it has a different capital letter. That's an interesting. It's the same, but it's different. Struck one seems to be the only thing that's not repeated. So hickory dickory dock, twice, lots of twices, a few little variants. And that's basically what it's looking for. So when you then say, what did the mouse do? It would say, well, the mouse probably ran, and it's going to be either up, out and down, because it did both of them. So I usually have if there's two options, I usually put an and or an or in front of it. It knows that probably. And then it'll say, well, run up what? And it says, well, the clock always comes after up or down. So all it's really doing is it's predicting when I'm talking about the mouse, it's not going to be talking about hickory dickory dock because that's not got the mouse in it. So when you talk about what did the mouse do, it says, well, the mouse either ran up or down and usually the clock. Now, if it happens after something, it's usually one of those lowercase t's. And if it happens before, it's usually a big uppercase T. So hence you get the mouse ran up and down the clock. And it's as simple as that. And that's all it's really trying to do. So it's very similar to your text in your phone when you're trying to do a text and it gives you the next predicted word. That's pretty much all it's doing. But more specifically, you think, well, how does it even train itself in the first place? So if you're trying to find out what is the capital of Paris. So Paris is what it's looking for. And it's going, well, Paris is what? I need to find the answer to Paris is. So you feed it a whole load of data. This could be from the internet, from text, from PDFs. It doesn't really matter. As long as it's got some structured data, ideally nice, clean data. What it then starts to do is just go, right, I know this data is full of these symbols, and I think they're called letters. It doesn't really care at this point. It just goes, right, this is what I've got to deal with, no more, no less. I will start just generating nonsense. And it will just keep comparing the nonsense, big long strings of nonsense, short strings of nonsense, just nonsense, using only what it's got in its training data. And eventually it might come up with something that looks like a close match to something in its training data. In this case, this kind of TH uppercase E. It says, I've seen that a load of times. There's something about THE. And for instance, it's much better than THEPX. I haven't found that anywhere, but it's got sort of the same letters in it, but it's a much stronger candidate for being similar. Okay. So then what it does is it then say, well, TH lowercase e, I seem to be finding that a lot more than TH uppercase E. I don't find that at all, but at least the letters are there. And likewise, when I say Paris is, the tends to come after it a lot more than cat. It doesn't say you found nowhere Paris is cat, for instance. It might happen somewhere, but who knows? So finally, what you can then do is you just keep rolling that on, keep training until it can find those words. And that's really what you're doing when you ask a prompt. Paris is, the next letter it usually finds after the phrase Paris is. Bear in mind, you've probably got encyclopedias. Paris is the capital. Paris is the economic center of. Paris is the capital is probably the next thing. And after capital, usually the word of happens, and usually the word France happens. And usually when it says France, it's got an uppercase F on it. And all it's doing is it's trying to figure out what is the most likely thing to happen next. And that's how those large language models work. So when you ask of it a question in English, it can understand it because it knows how that works. And it gives you answers in the same format. There you go, large language models, that's the beginner's guide. Now we come to images. They are very different. They use what's called diffusion models. So when you do diffusion, what it really means is you do the same thing. You start with some nice clean images, lots of dogs. I'm going to try and generate a dog. So you take all your pictures of dogs, and then what you do to each one of those images is you take every pixel and you turn it back into just random noise. So imagine a pixel, and then you just record what you did to it. You just say, well, generally speaking, in the middle of this picture is a pixel that I take it from brown, usually, maybe black, maybe white, to noise, okay? Each time you train, you make a note of what you did to it. So imagine every single pixel for a dog has a different journey to get to noise. But broadly speaking, the ones in the middle seem to be brown, and within the brown there seems to be these two black areas, and generally they're sort of near the middle but symmetrical, and then there's maybe a brown or a black thing in the middle, which is its nose. But it doesn't care what it is. It's just saying what happens to every pixel to turn it into noise. So then, if you can then add all of that together into one big model and then say, let's just start with noise, and now we need a dog. So all we've got to do is say, dog, I know dogs. So just take all of that data and start to then generate those pixels back into dogs. So you reverse the algorithm essentially, and you say, what do I need to do to every pixel to make it into a dog? And eventually you will get something that looks like a general dog. Okay, you run it again. It adds a little bit more temperature to the algorithm. You get a different dog each time, but it knows, broadly speaking, probably when it's doing a dog, the outside is probably green or something, or sky. So it always does green or something or sky around the outsides, and then the middle has got lots of brown with two symmetrical dots and maybe a dot in the middle, etc., etc. So the more you can train it, the more it will know what to do with this, what's called sort of the latent space. There you go. And that's how diffusion models work. Again, very, very simple. We're taking a few liberties with it, but that's broadly speaking how that works. It's not the same as a large language model. Now, does it know everything? Can you ask any question of a large language model or any of these models? Well, no, you can't. I've mentioned in a previous video that they are trained. When they are trained, they are set. So GPT-3 was trained up until June 2020. GPT-4, the most recent one, was only trained up until September 2021. So that's nearly 2 years ago when I'm recording this. Now, if you can add plugins to that, then that means you get access to the brand new data that's current through various means, but essentially it's a top up to the model. So if you're using ChatGPT-4, for instance, with a plugin, you can get real-time data. So now you can ask of it, who is the Prime Minister? What is the stock price? All those, who played for a certain football team. It'll be able to go and get that live in certain ways. So there you go. So it doesn't know everything. You need to be very, very careful when you ask of it certain things, that it can only be trained on what it's got. Now, how do you interact with these? Well, you use a prompt, and you can be better or worse at prompts. Now, this is a basic prompt: generate a picture of a fish running a marathon. Now, perfectly plausible, I guess. If you then ran that, it might give you a photograph of a fish. It might give you a painting. It might give you an illustration. It might give you a sort of Photoshop montage of a fish. So maybe a better prompt would have been, generate a picture of a fish running a marathon, real photography, Fujifilm Superior. I'd like it to be in full HD, taken on a Canon EOS. So you've got that sort of the lens that you would have, and you can even specify, what field of view you've got, all that sort of stuff. I mean, 35mm frame. I want it a 4:3 ratio. So you're giving it much, much better prompt. So the more you can add to a prompt, the better. And you'll see in lots of other systems that you can see other people's prompts. You can see them hammering away trying to get the perfect image that they actually want. Now, this is very different from prompt engineering. A lot of people get it confused. They think prompt engineering is being really good at prompts. That's not really what it is. Prompt engineering is what happens to a large language model to be able, or actually happens to a foundation model, to be able to accept a prompt in a certain way. So if you go to let's say ChatGPT and ask it to do a limerick, it's been trained to know specifically what a limerick is and therefore respond with that. So it almost gives it sort of subsets of prompts that it knows what to do. If, for instance, you said, give me a fax format for this, it will say, well, I don't really know what that is. I can't do that. So it's not been prompt engineered to know what that prompt is. So just it's about training the model to respond to a prompt. It's not being a really good engineer. So there you go. Now, what is a large language model? Now, this is really going back to the beginning of it, really, but a large language model, very, very simply, is owned by lots of very big companies because they are expensive. They take a long time and take a huge amount of data to actually train them. So you might train them with internet archives, bespoke data, documents and files that you may have in a separate archive, books and literature. Now, ideally, all of these are open source and you haven't used any copyright material to do that. But then out of that, you then have lots of types of models. So for instance, your prompt engineering, but you might be able to do, for instance, code, you might be able to generate news, you might be able to generate images, all those sorts of things as well. So it really is the training set. Now, how do you actually train it? You may never get to need this, but it's important to know. Now, on the right-hand side here, you can see a visual, guide to what an embedding might look like. And it does not actually look like this, but what an embedding is when you train these large language models, as I've mentioned before, it tries to figure out which words or which letters or which images or which parts of code are quite close to another. So that if you type in the word the, that might be close to a lot of things. If you say the word capital, then it might say, well, I'm probably going to expect the word Paris. It's going to be Paris, London, Beijing, whatever it might need to be. So certain words in certain situations have a closer relationship to other words in different situations. Now, all of that is held in this big thing called an embedding. And within the embedding, it's just another word for database, really. But in that, every single word in every single context you might have has what's called a vector. So the word the, fine, it has a load of vectors to everywhere, and they're all relatively loose, I would guess. If you then say the words MotoGP, then MotoGP is probably going to have a word bike or championship or track, something like that. So it's going to have some very close vectors with something that is relative to that word. So certain words have very strong vectors to other words. Some words have very loose vectors. So, but the embedding keeps a note of all this in many, many different dimensions. It's really hard to actually visualize, but this is a good example. Some of these images are closer to others, some of the lions, but they're also close to images of the same color. So even when you say a picture of a lion, it says, well, it depends. There's a vector between it and its color. It's the word lion is quite close to line. So there's another vector towards a word that is similar. Lots of vectors. So that's what's held in those databases. And that's why it's so difficult and so expensive and timely to actually train these things. That's what the big companies are doing. Now, how does it all fit together? As an example, you would start with your foundation model. On top of that, actually, you'd probably have your large language model, for instance, so it's kind of what's it actually doing. And on top of that, you then give it access to some data. Now, you might be able to do that separately if you're training your own model. If not, you would have plugins that can then connect to other data as well. And on top of that, you then give it a user interface. So it's a very, very simple way of thinking. Right at the bottom of this, then you don't really have much control over that foundation model and how it's actually trained. Towards the top, you can set your own interface, you can do your own plugins, you can maybe sort of set the data it's got access to, and then below that, maybe you don't. So that's generally speaking, at the bottom of this, it's supported by the big companies, and then at the top of it, it's basically developed by you. Now, when we get to the end of this, how is this actually processed and stored? Where is it all? Is it all in the cloud? Now, it kind of depends. So first of all, those large language models are all in the cloud. So they are owned by the likes of IBM, Google, Amazon, Microsoft, what Microsoft use, actually OpenAI, Meta, etc., etc. So those large language models sit in there. Now, do you is it private? Well, it depends. It depends whether you've got a consumer version of it or an enterprise version of it. But generally speaking, could you consider it private? You go, it sort of depends. And that's the big thing. That's why you always need to talk to the working group, etc., etc. Now, after that, you can say, well, the plugins. Now, the plugins might be less private in certain situations, who knows, but basically they might be accessed by other people. So when they say private, it's just they are accessible by everybody, okay? And the data you get back from it might not be specific to you, and so you need to super check it as well. But possibly internally, you can, for instance, have things locked down locally. So you might be able to set a plugin to be private, for instance. So bear in mind, you can actually do quite a lot of development in-house, but you always need to go out for your large language model. You may need to go out for your plugins. You can also make the plugins in-house as well. So just be aware that other companies, and I've just chosen BT, Deliveroo, Tesco, could have chosen literally anybody here. They also have access to both the large language models and the third-party APIs and plugins as well. So just be aware that what you're actually asking for is probably also available to a lot of other people as well. So if you ask of it what some business advice, it's giving that business advice to everybody unless you're using a local instance. So when I'm talking about privacy here, it's just how much access do you have to very, very specific data that's only for you. Now, the last slide in this, I think we're nearly through it. Hopefully you're all okay. Is my data being trained into these big foundation models? So if I'm using free stuff online, I think the best thing is just at the top of this to always assume that it probably is somewhere along the line. It's really, really difficult to know how these are being trained, especially if you have one of the maybe ChatGPT or you're going to Midjourney, something like that. Then it is probably, yes, it probably is being used in public. So what you then want to do is go, what do you do about it? Well, if you're doing anything these whatsoever, then go to the Gen AI front door, because there's lots of advice on whether you should even be using it or not. So chances are it is improving the foundation model. Now, also, if you are using an enterprise version, that same sentence, it's safe to bet to assume that it already is. So if you're using an enterprise version, there's usually an option to put it into private mode, essentially, and you can then do your own private stuff, and it doesn't actually get used to train the model, or it's in what's called a sandbox. But the basic advice there is, okay, you probably need to go and have a chat to the working group to actually find out whether it is actually as private as you think, and therefore what should you be doing with it. So hopefully all that has made sense. Hopefully you've got a better understanding of what it's all about, and we move on to the next one. Who are the big players in this space? Well, let's find out. You'll be no surprise, I've mentioned it throughout a lot of these videos, that the big companies are the big players. So those are the companies that can afford to train this and have got the time to train it, have also got the impetus to do this because their future probably depends on it as well. So OpenAI, Microsoft, Google, IBM, Amazon, and there's quite a few others as well. This is not exhaustive, but these are the big companies that you would probably base a lot of your models on top of. Now, each one of them has their own version of what everybody else has got as well. So they've probably got their own, well, they've definitely got their own foundation model. They've all got their own large language model. They've all got a chat version of it as well. So they've also got an image thing. So you've got DALL-E, for instance. And by the way, OpenAI is also the supplier to Microsoft's, hence why they're exactly the same. You've got Palm for Google when it comes to the large language model, etc., etc. I'm not going to go through them all. You can see them here. Point is, they're all playing at the same game. They're all trying to be the winners in this market, or at least be better for certain things than others. They all also have their platform underneath it as well. So, for instance, if you do go to OpenAI, they have their OpenAI API where you can access and you can develop on top of that. Microsoft have Azure, for instance. IBM have Watson X. AWS Bedrock is what Amazon provides. So just be wary. They're not all the same. So if you want one thing, they might not be available on other. But other than that, and likewise, Sky has affiliations, or at least doing some demos and proof of concepts with some of these. And we also have suppliers to our technology stacks already, and therefore it matches up. So some of these are off the card. Some of these will be very much who we work with anyway. So those are the big players. There are a lot of companies in this Gen AI space as well. Here are just some of them. And as you can see from some of the labels, there's video, there's biotech specific, there's gaming specific, there's audio specific, text and research and images. So you might think, actually, I need a bit of research, in which case I could choose any of those. Well, not really. You need to be very careful which ones you use. As I'm saying all the way through this, speak to the working group, go to the front door and find out what we can and can't use. There are lots of in there, but you shouldn't be using any of them without getting sign off first, quite frankly. There might be some companies that you do actually hear of. You might be trawling LinkedIn, you might be getting news updates. NVIDIA, it's always worth checking in with them. They are sort of pioneering the hardware and software behind AI as well. So it's always good to check in with them just for inspiration, all of these. Hugging Face is more of an open community. It's where you can go and sort of play with some demos as well if you really want to. But that's basically all on their side as well. So you can use that as a platform. If you are a member of Hugging Face, you can sign up and you can actually develop there as well. Midjourney is also for images. I've mentioned DALL-E 2, which is the OpenAI version of it, but Midjourney is a completely separate thing, and arguably it creates much, much better images as well. Now, there is a big problem with it, which I'll come to in a later video, but Midjourney is very public when you actually ask of it an image prompt. But that's one of the things you will hear of, and that's why you will hear of it. If you ever hear of it for corporate use, everybody will just close their eyes and go, no, because it is so public, you need to be very wary of it. Copy AI is just a good example of generating copy, for instance, for content, for social, for online stores. Respeecher can clone voices. So if you work in broadcast or something like that, and obviously if you have the rights to do it, then you could use respeeching. But it's also used for things like continuity announcements and things like that, where you might just want to do a pickup in between. You don't really need somebody to come in and do the recording. Runway is all about video, especially if you look at Runway Gen 2. It is mind-blowing what they can now do. And if you went there last week, I suggest you go there this week, and by the way, next week as well, just to see how quickly it's improving as well. LibreChat is more like a flexible clone of ChatGPT. So it's more like that. It's not really open source, but it kind of is. But that's basically what LibreChat is. So it looks exactly the same, but it isn't ChatGPT. And then you have Adobe Firefly, which I've mentioned before. It adds all of this prompt and generative AI image-based stuff to essentially the Adobe suite as well. So those are some of the names you should really know about. What are the main watchouts and issues? as you can imagine, there are lots. Here are 8 that I think are very, very important. First of all, we have bias. So training the large language models, diffusion models for images, for instance, and even the foundations they sit on might contain bias. They are only as good as the data they have been trained on. So you need to be very, very mindful of watching out for that as well. Personal data should go nowhere near these models right now until you've been to the working group and you've got absolute sign off, you've got compliance to look at it, all that sort of stuff as well. So don't even think of going anywhere near something like ChatGPT and just seeing how that database or that PDF that you got might work. If it's got personal data on it, that's super, super no-no. Proprietary information, i.e. stuff that is unique to us. So again, if you put some code onto it and say, could you just refactor this? That's proprietary information that only we own, that is unique. Do not put it into these models unless you've been through the working group to make sure it's okay and you've looked at all the legal requirements. And likewise, business confidentiality. Do not go anywhere near this with, for instance, you're trying to get a new image for a show that we're about to launch, but nobody knows about it yet. Don't ask any of these images models to try and generate something, because that is confidential information. Likewise, don't put contracts into this, etc. So keeping secrets secret is very, very important. Moderation is also something that's important as well. So ensuring that humans are actually checking this stuff as well. So let's just say that you do have a good case for this and it's gone through all the right things. You might still, well, you will still need something to be checked by a human at the end of it as well, just to keep track on it. Ethics has many layers to it as well, not only the bias issue, but also you might actually be affecting another ecosystem by the work that you do on it as well. Likewise, how do you protect your customers? What rights do you have? And what sort of duty of care do you have for your employees as well? There's lots and lots of layers to that. IP rights is really unclear, from what goes into the model to also what can you do with the results that it generates as well. Who owns those and what rights do you have to that? And again, moderation. You might generate an image, but it might have an artifact that is actually from some other training data that shouldn't be in your image, for instance. And security is a really important thing as well. So you can connect this to your internal database. Of course you can. However, that is a really bad thing. It should not have any access to our production databases or networks. And likewise, there are lots of emerging threats about cybersecurity as well. Things like prompt injections, where you can get these models to do things or return certain things because you've done something in your prompt or in the training data itself. So those are the 8 that are the main ones. However, there are some slightly sort of curious ones as well. Hallucinations is a word that you probably need to know about, and it's the tendency to try and give you a believable correct answer, even though it might not be factually correct. So the sentence will make sense, but actually the facts within it might not. Or for instance, if you said, I'd like an image of shaking hands, it knows that there's always a hand at the end of the wrist. And therefore, if it generates a wrist, it might try and put another hand on the other end of the wrist as well, in which case you get this weird image that you can see in front of you. So that's what's called a hallucination. It happens in text and in images. And also just be aware that you are getting generalized responses. The whole point of these large language models is they predict what comes next. And the most obvious thing to come next is the most average thing that it's found before. So if you are asking of it some business advice, for instance, and this prompt here, which you can see me trying to say, I'm a coffee shop in central London, what should I do to make more money than my competitors? It's going to give that to anybody asking a similar question as well. So it is not going to be unique advice and it's not going to give you any business advantage whatsoever. And there's also a slightly nefarious thing called poisoning, where you can find people either maliciously or just giving inaccurate results through the training of that data or through some manipulation thereof. So just be aware that sometimes the training or a plugin that you're using, there might not be the most pure way of getting it. So poisoning is a thing, and it can be an active thing as well. Now, this is how difficult is it? So ChatGPT, yeah, just log on and use it. Of course, enterprise is fiercely difficult, and there are a lot of steps that need to go through it. So just be aware, if you even go anywhere near this in a Sky sort of business context, then the working group is the thing that you need to go and have a look at and contact. So things like having a play in the web in your own time, maybe on a bus, doing your own thing, trying to put a wedding card together or something like that. That's dead easy. What gets a little bit harder if you're a developer trying to set up a local experiment using a few plugins. Again, you might be doing that at home. That's fine. As soon as you then do it in a business context with business data anywhere near Sky, that's quite hard. You need to go and speak to the working group. If you then try and do it at an enterprise level and deploy this for every employee or customers, it is fiercely hard. So it's the equivalent of, a toy car to a VW Beetle to an F1 car. It might just be the same thing, but it certainly isn't the same thing. There's orders of magnitude of complexity between them. Just be aware, you might have a great idea whilst you're sitting on the bus. When it actually comes to making it internally, it becomes a very big issue. And also, just be careful what you share. Now, I would suggest that, you shouldn't really be using ChatGPT and Midjourney. However, knowing that they do exist and people do tend to try them out, and it's almost the gateway drug to generative AI, ChatGPT is actually being used, and because it's the free online version, everything you type into there is viewable by the developers, so OpenAI. So whatever you do not put any private or privileged info or code into it. Whatever you do not do that, just because it's training their data set and is visible to them as well. And that's what's in the terms and conditions, which you probably haven't read, but you probably clicked yes to. But also, and which you should have by, so therefore you know what to do. And Midjourney as well, if you haven't played with Midjourney, it's actually accessed through a Discord interface. Discord is a public place. And even this example I was trying to put here, I didn't actually run these, by the way, a poster for a TV show that has two contestants dressed in lycra and sequins. So I'm just making up a prompt just to show you so I could do a screenshot. But right above it was actually somebody trying to get a logo done for their company. And they'd pretty much typed in their business case into that to try and get the logo generated. Everybody could see that, I could see it. So with Midjourney, it's especially dodgy. So these are out there and people tend to try and have a go of them, but just be aware they are almost the most dangerous platforms you can experiment with. So just be super aware of that. Hopefully that's been useful and there's more to come. Are there any legal things or policies I need to know about? Of course there are. So luckily Sky has some quite robust guidelines around this already. These are of course available on the Gen AI front door. However, I will read them out because they are super important as well. So no confidential information. So if you're doing anything with generative AI, well, confidentiality is critical. So don't use any confidential information. It's not to be used for production in any way. And that's either for customers or for employees as well. So we cannot guarantee that it's unsuitable or there's no copyright stuff in there. So we cannot guarantee that. So do not use it. Use it internally if you have a permission to do so for generating internal things, maybe for scamps for your new creative campaign, but those should not go external and should not be shown to customers. And do not connect it to the Sky networks or infrastructure. The cybersecurity risks are multiple. And also, you must get approval for the intended system. There are many ways of doing it. You might have a friendly AI company phone you up and say, we can do a thing, sounds attractive. However, you need to actually make sure that you've got sign off for that and it's gone through the working group. Also, just to make sure that nobody is being duplicative and everything needs to be also well documented as well. So whatever you do, you need to document very carefully what you're doing at every step. And also you need to make sure that you meet and exceed probably the policy requirements as well. And these are also listed as well, which you can find elsewhere. So again, they will be on the front door and you will also find those through the working group as well. You're sensing a little bit of a style to these as well. The working group is where you need to go. However, you also need to be aware that the risks are not just get it signed off at the beginning and you're good to go. It's all the way through the life cycle. So you might even be thinking of a proposal. Is this a thing? Well, go and have a chat to the working group. And then once you've got the nod, you scope it. Okay, how do you scope it? Are there any legal requirements within that? Then there will be some policy around that as well, and lots of people there to help you. Again, design through to development, all of the APIs you might be using need to be checked as well, and through to deployment and how accessible is it, cybersecurity risks, and then to support as well. How is it supported? How is it kept updated? And is it patched? All those sorts of things. So just be aware that it happens through every step of the cycle, not just at the beginning. And you need to check in every single step as well. It's really important, especially now that you are really on this. Lots of other companies are also looking at different things as well in terms of guidelines and legal responsibilities, and it's a very much an evolving landscape. So from individual companies to entire countries, they've all got their own approach to this as well. Comcast, for instance, has a very good set of robust guidelines around this as well, and Sky's approach will very much lean on that as well. So just be aware on a company level, lots of companies have their own versions of it, as do we. There are also consortium levels as well. I've mentioned this a lot. So Meta, Google, Microsoft, Anthropic, for instance, have a large language model and a foundation model. You might not have heard of them, but they've all clubbed together to say, like, we will actually have a voluntary code that we will follow. And therefore, hopefully that'll keep us safe. They're really doing that to make sure they don't actually get under the guise or the gaze of, for instance, the US government, who are currently also have got their rules in place. So consortium level, you might find they're banging together, usually with a voluntary set of codes as well. The reason I mention it is it's worth looking at what those guidelines are. And sometimes on a state level, there's also an evolving regulatory landscape, shall we say. So Italy, for instance, earlier in the year banned ChatGPT for a while whilst they assessed its GDPR compliance, basically. And also on a state level, you got people like New York or states like New York also saying that things like employment law, you can't use these generative AIs to be anywhere near if you're going into hiring and firing, basically. There are now regulations around that. Again, that's a good sort of ethics level to go and look at as well. And also on a country level, you got people like the UK, also the US, the government are actually coming out with their rules. And some of those are biased towards maybe their citizens, and some are also biased towards maybe more a commercial or investment orientation as well. So just be aware, from a company all the way up to a country, there are quite a lot of guidelines already out there, and they are constantly evolving. So you need to constantly check in as well. So to that point, you need to constantly check in these. They are evolving. There are people in Sky who are looking at these as well. So you don't have to be across this all the time. The compliance department, legal department are all on top of this as well. So please go to the Gen AI front door to find out what the latest guidance is. Okay, I want to get involved. Now what? Well, it depends on what level you're at. If you are relatively new to this still, and you've got your brain is fizzing away and you want to find out more right now, then that's where the Gen AI front door is your friend. So head on over to there. There is a link on the next slide, by the way, so don't worry about that. But also my advice to you would be just go and check out all the advice, the guidance, because it does change regularly as well. There's a lot of resources on there that would be super useful to you. If you have an idea already, then you need to get in touch with the Gen AI working group. They will help you through that idea from the initial stages all the way to sort of getting it started in production as well. My advice to you there would be, don't do too much work before you get in touch. It might be an idea that we're already working on, or it might be an idea that has been deemed too risky right now, or anywhere in between. So don't do too much work. Just go and get in touch with the Gen AI working group as soon as you possibly can, and just ask them about the idea, talk to somebody, and they might even assign you essentially an expert who can help you work through your idea as well. Now, if you're ready to go and you've done some research and you've done the whole thing and you've definitely got a use case and all that good stuff, then you still need to keep in touch with the Gen AI working group all the way through. Now, this is a new area, so your working practices or your timelines or the way you do things will probably change. And also, if it's a new thing and it's a new thing to Sky as well, we'd also appreciate actually learning from your use case example as well. So you just might be expected just to slow down a bit and go through a few more steps. So just be aware of that. Don't put a timeline in there that is based on your current workflow. Now, here are some useful resources. As I said, now I'm aware this is a video, so you can't click on these, but they should be available on a PDF that comes with this. They are clickable in that as well. The Gen AI working group is there. I've typed out longhand the front door, so you can pause the video and type that into your browser if you really want to. There's also some really good resources as well. If you want to and explain of what ChatGPT is, then Kyle Hill has a really good YouTube video. You could probably just Google that. There's an LLM explainer that the New York Times did, which is super useful as well. You can sign up to the New York Times and get some articles for free anyway. If you've gone over your allocation, I didn't tell you this, but if you do press escape before the paywall, you can sometimes get underneath it. And there's a really good Gen AI companies overview on that link, which you're going to have to wait for the PDF. But keep in touch with the startups that are happening, because they tend to signal where the investment or growth is in the market as well. And also there's a really philosophical video that you can probably watch there again, wait for the PDF and click the link on as well. It's always useful to have an open mind to generative AI and just to have a wider sense of where it is going. So definitely worth a look. Other than that, thank you. You got to the end. Well done. Well done for both of us, I suspect. So if you'd like to find out more, there's the email, there's the front door. Other than that, please do go and have a look at the front door because all the next things will be on there. Good luck, farewell, and use it responsibly.